Garrett Bruhog. Episode 100. You are number 100. Congratulations, Garrett. You don't get to win anything. There's nothing I have for you. Just some arbitrary numbers. But
nothing explodes anywhere. There's no flyers.
No, I was thinking maybe like get some confetti and like some like dancing girls and like a monkey with a cymbal. But no. So hey, 2 different hundreds. Joe Rogan just signed a $100 million podcast deal with Spotify. And I just hit episode 100. So, I mean, we're pretty much the fucking same, right? I mean,
pretty much, man.
I mean, tomato, right? You know, so, but yeah, dude. So, what's going on?
Oh, just trying to do some science, you know. We're restarting the lab here in New York ever so slowly, and I'm got a list of things to go through, trying to plan experiments for 2 months. You know, it's kind of crazy to think about the impact that like this COVID thing's going to be felt for years, because you know, you think we're 2 months behind on our schedule for doing experiments, but we're actually more than that, because there's lead time needed to get things going. Right now the lab won't even start doing experiments for another week or so. They're just checking the lasers to even make sure they work right. And there's a whole question, like these things haven't been turned off in 15 years. We're kind of concerned are they going to come back the same?
Jesus.
Target lead times, all sorts of stuff, but like trying to get companies to start building stuff again. This is, you know, 6 months plus of lost research effort, I'd say.
It's kind of paused progress. For everyone that's listening, hey, Garrett is studies. I think you submitted a report. You study nuclear fusion at the University of Rochester. What did you submit? Because I remember we were talking about that on emails. You said that you finally submitted, what was it, a proposal?
Oh, yeah. So I'm not in the fusion group directly. I'm in the high energy density physics group. I thought that internal reasons, but that's the point of the lab, is to work on inertial confinement fusion. And I submitted a proposal to lead my own experiment for the first time, like at the big level. And so, you know, I'll hopefully hear back soon on that. But that was a lot of work. I've never done that before, and it was, you know, it'll be fun. We're going to try to do something new and unique, not with fusion, but with the main thing that I'm actually focused on in my PhD is developing new sources of radiation to act as probes. Because when we're trying to study these experiments, you know, you think about like when you're experiencing the world, right? You have your 5 senses, and I know people who study the humans are probably going to tell me I'm wrong, and there's like 15 or whatever. I don't know. I'm going to go with 5.
Okay.
Right? You get your 5 senses. Sight is your primary sense. When you see, you're only able to see something like 400 nanometer bandwidth of optical light. That's all you can see. You can feel a little bit of the infrared, and you know, we feel sunburns with ultraviolet, but essentially you can't detect anything else. When we're trying to probe these systems, not just at my lab, but also, you know, when you look at tokamaks and all these other fusion experiments, we try to use every possible diagnostic we can put on them. And some of the magnetic guys, the tokamak guys, have a real nice advantage in that their experiments are long. Even if they're pulsing for seconds or milliseconds or whatever, that's ages to most of these detectors. And they're able to fire up all sorts of ways to probe the plasma. And their plasma is really diffuse. It's not even, most of them don't run anywhere near the number of particles that are in just the air you're breathing. They're essentially hot vacuum. On my end of things, with laser compression, we're the exact opposite. We take things up way beyond the density of lead. And yeah, I know it's hard, and it's really hot too. And we have very short time scales. And so there's, you know, beyond just the fusion experiments, just the trying to understand matter at those conditions, which is a big deal for understanding planets and stars and all this really cool astrophysics stuff. And just trying to understand matter in general. A big thing that people are working on is high temperature superconductors. So as you compress matter, we're finding the weirdest things suddenly become superconductors at high pressure. And we don't have a good theory for superconductivity, what we call high temperature superconductivity, which is the superconductors that work at liquid nitrogen temperatures. And they've been able to push the temperature up way higher with high pressures. We don't understand why. And if we can get a grasp on that, the hope is that we could make a superconductor that works at the room temp or near room temp, even if it was like, freezing temperature of water. It'd be trivial to put that everywhere.
Yeah.
And that would change the world. That would be a bigger deal than fusion, and it would make fusion easy.
Easy. So having a superconductor that you could go at 32 degrees Fahrenheit, that would change the. I don't know. I know what a superconductor is in the same way that
So yeah, let me explain a couple cool things you could do with it.
I know the buzzword superconductor.
Yeah. So about 30% of the electricity we make, doesn't matter how you're making it, nuclear, coal, solar panels, whatever. About 30% of that is just lost in heating the wires.
Okay.
And we're already working really hard to lower that. That's why we use these really high voltages for transmitting power everywhere. You use a superconductor, you lose zero. Absolutely zero power. And on top of it, how does it work?
Yeah, I was going to, well, how does that not, again, please take my hand and walk with me through the land of physics. But it's clearly not, my idea clearly isn't correct because it's possible, but I feel like that violates thermodynamics. There's zero heat loss. How does that?
So it's not zero heat loss. Superconductors can still lose heat. We have to work to keep them cold. That's why we don't use them for transmitting power right now. There is zero energy loss from the electricity. So if I have a battery and a load, and I connect it with a normal wire, that wire actually becomes part of the load because the wire has to heat up. With a superconductor, it doesn't. Okay. It's like a magic connection between the two. There is no loss in the superconductor. And the beauty of that is that the main area where you actually see it used is in big magnets. If you ever had an MRI before, that's using superconductors because the superconductors can carry huge currents, and currents are what drive magnetic fields. Current is also what drives resistance in the wire and heating. So when you want to make a big magnet that just uses copper, you also have to have a swimming pool worth of water to cool it off.
Yeah.
And you're wasting all the energy. Superconductors, especially like MRIs, can do this really tricky, crazy thing. So if you imagine you had a loop of superconductor, perfect loop, and initially you leave one little piece that's hot. And when a superconductor is heated up, a lot of the materials aren't even metals for the really cool new ones. They're like ceramics and things like that. So they're worthless. They won't conduct electricity at all. But when they're cold, they perfectly conduct. And so you hook up your leads to this loop and you start pumping electricity in. And you're like, okay, we got that part running, the circuit's going. And then you cool that piece down. Now the electricity sees that the initial ground that you had provided is super high resistance compared to the superconductor because it has resistance at all. The superconductor basically has zero. So the electricity is like, screw that. I'm just going to stay in the loop. Yeah. And it'll just circle and circle and circle and circle forever. Okay. And so MRIs, they don't have these gigantic Mongo kiloamp power supplies running to keep the superconductor going. And they don't have to, bring a power plant up just for the hospital to turn the MRI on. They just trickle the power in to charge them up when they first start them up. And then there's just a little, like a battery trickle charger that puts a little bit of power in because, like you said, nothing's actually perfect. Over the course of months, the superconductor will lose a little bit here and there. There's a small bump in the crystal or a cosmic ray fucks it up or whatever. But it's absolutely crazy. And one of the things you might be thinking, one of the other things you can do is you can store energy that way. Yeah. And so you can, you imagine you have a room temperature superconductor. That makes a very interesting sort of battery. Yeah. And it's right now there are actually superconductor storage. It's called SMES, SMEs. And that's being used at a very tiny level for balancing the grid, because one of the nice things that sort of energy storage can do is it can do these small variations to like adjust the frequency and things like that. The actual power grid is way more complex. It's one of the craziest, most complex thing man has ever built. And it's amazing every time the lights turn on. Like, you should thank God the lights always turn on, because we're having to balance this psychotic system, completely varying, no control. There's not someone from the power company telling you, oh, okay, this time you can plug in your computer. You just plug in your computer.
Yeah.
You just plug in your electric car. You just do whatever. And they balance that. They're able to modulate all of that. And that's incredible. And that's why there's all of these things like peaker plants, distribution stations. Energy storage is becoming a big deal there because it's cheaper than peaker plants in some instances. And even really big power plants for like baseload power. Like, one of the things that's important for keeping the grid stable with nuclear power, you'll hear people talk about baseload. Baseload is in and of itself important, but the nuclear plants themselves actually help keep everything in the grid on the same frequency, because the grids in America is working at 60 hertz, and those huge monster turbines in the nuclear plants are telling the rest of the grid, you have to obey me. You have to do what I do. Because if things get out of phase in the grid, it's bad news. So you don't want that to happen.
So grid operators or upkeepers, they're the unsung heroes of society.
Yeah, so a good friend of mine works on this sort of stuff. And everything, it's just witchcraft in my opinion. I can't believe it works.
You salute him. It's man, that's like the guys that like dedicate their lives to like, standing on the wall on watch for the invaders. Like, I almost, for me, I almost kind of like that I don't know how it works, because it's just one less thing for me to think about. For this, I don't know if this is related at all. I just think whenever there's just, again, a couple like buzzwords that I almost just kind of throw into a big soup of stuff that I don't really understand. Have you ever seen those videos? I think it's called quantum locking or quantum levitation. You ever seen those things where it's like
with the superconductors that are levitating,
like the magnet they'll put on like the thing, and
mm-hmm.
there's like the liquid nitrogen.
So that's a superconductor. They're cooling that puck down until it becomes until it enters its superconducting state. And then a weird thing that superconductors do is they expel all of the magnetic fields that are in them, and it makes them push off. It's a very slick trick.
That stuff is pure like Hogwarts shit. Like, if you're anyone listening, look it up. Look up like quantum levitation or quantum locking. They'll put them on like a whatever track it is, circle or a figure eight or whatever, or Mobius strip, and they'll have these. Yeah, it's like a puck, and it's like there's like steam coming off of it, and you just kind of tap it, and it will fly around, just not touching anything. But then they'll pick up the whole track and turn it upside down, and this thing is still not.
Because it's locked to the magnetic field line. So that track is neodymium magnets, like those little expensive silvery ones. So here's the crazy thing for you. If we get room, let's say we got room temp superconductors tomorrow, you'd have that puck, but it would work forever. Rather than having to cool it off and it'd be blowing steam and all this stuff, you would just grab the puck, toss it on there, and it would never stop. It would always be levitating. And so you could do stuff like maglev trains would be way cheaper.
Yeah.
They'd be way easier to make. Yeah,
it's shit. If you could create one of those pucks on that little ring, why not make one around the equator? You just fucking hop on it, whatever. Just literally go day drink on a puck around the world. Just like
one of the other cool things that would come from all of that is you'd have way stronger magnets, and it's going to be weird because I was just talking about running it at room temp, but if you cool a superconductor way below where it normally operates, every superconductor has got a magnetic field at a certain temperature and a certain current. There's these things coming into play, but just believe me that at a certain point, they'll stop being a superconductor. Like if you just keep cranking the magnetic field up, it will break the superconductor. And one way to get around that is you cool it way below its critical temperature. But if the critical temperature is really high and you cool it to the same point that we're already cooling these things, all of a sudden that magnetic limit is way up there and you can crank it way more. So right now for like particle accelerators and fusion experiments, we're limited in this 16 to 20 Tesla, I think is roughly where the absolute biggest magnets are being made. But if you were able to crank that up another couple hundred degrees, maybe we'd get 80 Tesla. You know, you could do something absolutely nuts that would give you, and the benefit there is for particle accelerators, it gives you a stronger accelerator, a tighter, better accelerator for physics reasons. And for fusion, it gives you a smaller reactor.
So that's like, it's like when you're playing like Grand Theft Auto or something, you can like get a car and you can upgrade like the engine and give it nitrous and turbo and it, you know, lower the suspension and do all these things to make it fast. You can make like a shitty Volkswagen into a sports car, or you can just save up your money and buy like a Lamborghini or a Bugatti, and they're already that fast. But you can also take that Lamborghini or Bugatti and go put in turbo, nitrous, lower, and you can turn it into a hypercar where it's just like, it's godly. So that's what you're saying. Like take this already magical thing and just
just keep making it better. Now, the problem, and this is why, you know, no, everyone says don't hold your breath on this. There's no guarantee this exists. There's no guarantee that we'll ever see one because we don't even understand what's making it happen at the high temperature regime. At the low temperature regime, we do. People won Nobel Prizes for that. That's well understood. At the 70 odd Kelvin and higher area, we don't know what's going on. And so it could be that we'll never see one, or that it will be, so me and my friends back in undergrad had a bet about this, that we think that there will probably be a room temperature usable superconductor. It'll be found at some point, I don't know, probably after I'm long dead, but they'll find one. But our bet, we would always joke about how it's going to be made out of the worst stuff ever. It'll just be made out of, you know, the rarest things you could have.
Yeah.
Pure iridium, rubidium.
Yeah.
You know, all this crap that there's only like 9 tons on the planet Earth.
Yeah. Yeah. What's the rarest? Is it?
Iridium's really rare. That was always my joke pick.
Yeah. Is it astatine?
Radioactive. Or you could pick, you know, francium, astatine, iridium.
Fuck that! You show up into the 110s and the like the uniums and the those ones where they get like a nanosecond. Yeah, it almost seems like but there's always this like.
The big thing is we just don't know. We really this is like, you know. Every now and then you hear people say something about, oh, well, when will we hit the limit of knowledge or whatever? Man, we're so far away. We're a grain of sand. We know a grain of sand in the entire beach.
Yeah. What was that quote from like the 1900s or something? Literally like 1900 something.
Oh, we should close the patent office soon because we think everything's been invented.
There's nothing left to do but like fine tune the measurements. And this statement was made before like flight. Like, dogs, you guys are counting your chickens, and it's like, dude, in the next 40 years, you're going to detonate a nuke, and by 69, you're going to walk on the moon. Like, it's, so wherever we are right now, that's my monkey brain sometimes gets to that point where I'm like, you know, what else really is there, you know? I'm like, the internet's pretty fast, you know, self-driving cars, okay, it feels like we're knocking on that door. And maybe stem cells.
It's the unknown. Like to paraphrase Donald Rumsfeld, it's the unknown unknowns, man. We don't know what we don't know.
Yeah.
And it's and on top of that, there's all these extrapolating effects, right? We like one of the things I think is fun to do is look at really old sci-fi.
Yeah, that's what I was going to get to.
Yeah, and sometimes they predict technology correctly. but they don't predict all the knock-on effects from the technology too. Like you get stuff where the idea of portable communication comes into play. Sure, great. They didn't predict any of the societal effects that come with it. Or like my favorite thing is their predictions on computers. They just had no idea what that was going to do.
Yeah. I mean, but it's like the Mesta 50, that 50,000 ton, what the hell is it? It's a press. It's like this huge press that we built in like late 40s, early 50s.
Mm-hmm.
And it's pretty much, if any plane you've ever been on has probably had something produced in the Mesta 50. I don't understand the importance of this, but that's not the point. The point is we have this massive thing, this 50,000 ton press. It's been operating since the 40s, still operates on like classified aircraft pieces. But like the point is like we didn't. So when we captured the Nazi scientists, everyone remembers like rockets, but there was a ton of shit they did, and one of them was they had these 15,000 ton presses, and the Russians got away with they were like 45,000 tons. So naturally, we built a bigger one because America. But it's like we couldn't have foreseen that this made planes cheaper and safer and more mass producible.
Oh yeah, the knock-on effects from things.
Yeah. So how many people can now fly? How many artists from rainy Seattle now go to Hawaii, get an inspiration, and create this movie that's Star Wars? There are these ripples that I don't think you can foresee unless you're.
No, impossible.
I mean, you really, yeah.
It's too random. Everything's perfectly random, and with humans, you have 7.5 billion perfectly random players in the game.
Yeah.
And you just can't predict. The most you can do is you can make the initial extrapolation, right? Like you can make that initial prediction of, oh, I can do this one thing, and that's what's inspiring me to build my new material.
Yeah.
But you'll never think about the 99 other amazing things that are going to come out of that new material you made.
Yeah. Yeah.
Like another really fun example with that is the laser. When the laser was first discovered, there's all these great articles of people just shitting on it. They're like, oh, that's a neat quantum mechanical trick. It's a solution looking for a problem, blah, blah, blah. Well, you know what? Look at where we are now. We have lasers everywhere. No one could have foreseen how cheap and small we'd make them or how huge and powerful we'd make them. And they're used for a million billion things. There's one in every supermarket.
Everything.
Just everywhere, and it's expanding. Like the military uses are going through the roof now. I just saw that they're going to mount one on an AC-130 now.
Yeah, I mean that's an inconvenient but important truth is that I saw a quote somewhere on Reddit. It was a comment, and I looked it up. I Googled it, and I was like, "How is this not a famous quote?" But I guess some dude just like unwittingly made this amazing comment. But it was, "War is the engine of progress." And I was just like, that is, but I'm getting off to a side rant. Have you read Nuking the Moon by Vince Houghton?
I have not.
It's like it's great. It's like a 1-day Audible listen, but it's like 5 plans that stayed on the drawing board.
I've heard about the idea of like nuking the moon just to show how tough America was.
Yeah. But yeah, so it's like they go into like 5 different like crazy things, like, the moon, that's just one of them. But then within each like section, he also goes into the history of everything that led up to it. But he talks about the laser and the guy, he talks about how much the guy got shit on for it. And it turned out that I think it was the NSA had been obviously listening and tapping everyone. And they thought that he was a communist sympathizer. So they put a national security, they slapped a national security patent on his discovery, and he wasn't allowed to work on it at DARPA. So they took it and they were like, "Thank you for your service, but we think you're a dirty commie." So yeah, but I talked about this.
Yes, in relation to that. Oh, I was just gonna say the little lasers that you see everywhere, the ones that are in if you still have a DVD player, or in the scanners at the supermarket, whatever. Those are diode lasers, right? Or the one you mess with your cat with.
Okay.
And diode lasers use some semiconductors. They're highly efficient, and you can obviously make them very small. And the funny part with that is when diode lasers were first discovered, they were widely considered to be the crappiest possible laser because the very first one made, it needed something like a megawatt of electricity put in to get a couple milliwatts of laser power out. And they had to cool it with like a swimming pool, and the whole thing was huge. And they just did it to kind of show they could, and went, man, that is a terrible laser.
Yeah.
And now, you know, it's like the best one you could get. Like nothing is better than that.
That's how it always starts. If you've ever listened to DARPA, The Pentagon's Brain by Annie Jacobson, she has a couple chapters on like the birth of the computer. Dude, these things were so almost like steampunk. Like, I mean, like
vacuum tube
punch cards, vacuums, and like cranking it up, and the buzzer went off because of doing too many calculations at once. And it's like, Jesus Christ. And it's like, yeah. And then it's like, now look where it is. And so it always goes on these insane, on a long enough timeline, it will go batshit. But yeah, so I talked about this with a friend a couple episodes ago. I have no idea when it was, but we're talking about, yeah, retro futurism or like old sci-fi. And there's these things, and just the medium itself is just a testament to how off it is. It's from a 1900s, like, I don't know, it was like a museum exhibit, and it's all done in watercolors on like canvas. And it's the year 2000. What to predict 100 years from today? It was like, you know, it was literally the year 1900. And some of the things are cool. Some of them, it's like people at a park and they have what look like, you know, like rudimentary, almost like if the Jetsons made an iPhone, but they're like FaceTiming. And it's like, oh yeah, they got that. But then like the other 99% is like, you know, they took what was available then, and they were like, in the future, there will be blimps a mile long, and they'll be able to carry hundreds of passengers, probably as far as between New York and Boston. Like, you know, hold on to your fucking pants, like, because here we go. And firefighters will have wings. They have these big like leather canvas wings, and like they have these like pneumatic contraptions in it, so they'll be able to fly up to a burning bell tower and put it out. And you know, they literally have on like bowler caps and mustaches. And it's like, now some of these may seem a bit fantastic, but it's like, but that's what all the shit is that. And it's like they took what they had and they just extrapolated that. But it's like,
and it's because there were unknown unknowns. Like they didn't know the jet engine was going to become a thing.
2 years later, Kitty Hawk. The entire idea is like, oh mate, you don't need a blimp, you know? And it's just shit that like you never could have, or using like artillery rounds to like send mail. Like,
oh yeah, there's also the missile mail idea in the 50s.
Yeah, and it's like
hilarious.
You could get it so quick, and it's like they didn't see the internet, they didn't see, you know, so it's whatever and it's so easy to look at them and be like, they're so stupid. But it's like, what are we doing right now?
We're making the same mistakes right now when we predict things. Like one of the best examples is you constantly in sci-fi constantly have this prediction that we're going to be farther out into space, right?
Yeah.
You know, there's this constant thing of, oh, you know, the Mars colony will start in 20 years. The moon base will already be up and running. And I love space exploration. I love the idea of going out into space. But if you actually sit down and think about it, you don't think fantastical. You know, the rate of getting out into space for humans is very, very slow, and there's no reason to think it will change. Space is hard on people, and space is expensive.
Yeah.
And so the motivation to go do any of those things is really, really low. Like you look at going to the moon, you go for the most optimized strategies out there. Don't look at what NASA's doing. Just, you know, use like some of the stuff from like Robert Zubrin or any of these big thinkers, or like von Braun when they talked about doing these nuclear shuttles to the moon. You're still way more expensive than anything else you can imagine, and it's way harsher living conditions. And you really do start running into a little bit of a question of why. What are you doing? You know, why? And especially in the age of robots, it's like, what's your motivation there, man? Yeah. And so it's that's the one that I think they get wrong all the time. You have to have some motivating factor beyond it's cool.
What about like asteroid mining?
I mean, to an extent, yeah, but there's also a whole argument of like, well, do it with robots, or maybe you have people up there controlling it, but they're not going to live. Why would you live up in space? Space is a rough place to live.
Yeah, I mean,
If you're going to be doing asteroid mining, you got to have pretty cheap launch, and
yeah.
you
But
got to have cheap landing.
I mean,
Landing's free.
yeah,
You got to come back.
yeah. Well, why do people get on the Mayflower? Why do people get in a covered wagon and go out west?
I mean, I
Mine.
agree with that statement. It's got to be orders and orders of magnitude cheaper for that to work. Not just launch, everything. So if you look at like NASA's plan, this is like, if you look at like what Elon Musk talks about for Mars, his plans are big and grand and exciting, and they're missing all of the nitty gritty of what it needs to actually live there. And it's part of what's stalled NASA out so hard on that. Is you start with the biggest problem, right? You're like, okay, we're gonna make a rocket, and NASA has probably 1,000, 1,000,000 rocket designs that they could fund, they could build, that could take people to Mars. Could have done it right after Apollo if we really wanted to. It's there. It depends how much risk you're willing to take, speeds you need, blah blah blah. But you can, it's within our grasp. But then you get into all the other difficulties. It's like, okay, we have the rocket that takes us there. Now we need to land. Mars is kind of rough. It's got pretty high gravity. It's got a weak atmosphere. That combines the two really shitty things, because we can kind of use the atmosphere, but not really. And, we're going to have this nasty hypersonic-ish landing. That's why it's so impressive when they land those big rovers on Mars, which will be launching soon. Perseverance in July.
2020?
Yeah, new nuclear-powered rover going to Mars.
How big is it?
About the size of an SUV. She's a monster.
Is it bigger than the most recent big one?
No, it's Perseverance is Curiosity's younger sister. So it's the same chassis using most of the same technology, but they've done a lot of upgrades, like better sensors, better computers, better wheels. Yeah. That sort of thing. But look it up. It's really sweet.
Hell yeah.
But then you figure out your landing, and you're like, okay, now we're on Mars, and you just problems and problems and problems and problems, because you can't go out and breathe the air. The radiation rates are way higher. You can't natively grow stuff immediately. So you have to start mining everything possible. You have to make these large structures. If I take a covered wagon out west, I can camp out under the stars. Every aspect of living on Mars takes way more effort, way more thought. And there's a lot of problems, especially with humans and making these sealed habitats that are open-ended, that we're not really sure how to go about doing. And the only real solution, in my opinion, for solving that, if you want to say go to Mars, the only real solution is you have to go into this assuming you're either going to go really small flags and footprints sort of mission. So you just burn through resources. You don't mine anything. You just preset a bunch of food, preset a bunch of air and water, send the best of the best. And if they die, they die. Or if you're willing to go for tons and tons and tons of, if what you're going for is long-term habitation, even if it's not tons of people, you have to be willing to move tons of stuff. Like Musk is right in the sheer scale, but I don't even think he fully grasps every bit of the sheer scale, because you have to bring all of Earth's industry there. Anything breaks, like you have your fancy methane processor to make fuel for your liftoff rocket, right? What happens when one aspect of the piping breaks? Do you have the equipment to make new piping? A lot of that piping is like you look at the coatings, like you have these aluminum steel alloys that have to be made in special facilities here on Earth. Like you have to have every aspect covered, because you can't call up Amazon to get delivery.
Yeah.
And there's no, a lot of this stuff, there's no second chance, because you can't go outside and breathe the air.
Yeah. It might just be like, no matter how much we plan and no matter how much shit we send, even if we
people are going to die. We're going to screw it up.
Oh yeah, no, that's accepted. I don't think anyone thinks no one's going to die doing that. But even if you just went all, I think the only way to go is like, you just have to start. Like, you just have to start, because no matter what, I think there's just a certain learning curve and some bumps and bruises that like are going to happen regardless. So like, I think the best way to go is like, just start, like, you know?
Well, and that's why I personally am a big supporter of going to the moon first, because it does give us that learning curve, and it's right there. And the moon, you actually can, like, you can go, oh fuck, I need help, and we can get you
Where we
help.
can get, yeah,
Or you can, you can come home. Like,
yeah.
you can get on, we can set up a little escape capsule and your ass can run back home pretty easily.
We can actually see each other.
Yeah.
Like,
And, there's not this crazy delay. Like,
yeah.
you and I could FaceTime between Earth and the moon, and we could talk through, like, oh, I need help fixing the majigger. And, you tell me which wires to pull, but
yeah.
not Mars.
Yeah. The moon's not even, is the moon even a full light second away?
I think when it comes to signal delay and everything, I think you end up about 3 seconds delay. But I think a lot of that is actually in, like, processing.
Yeah. Well, that's nothing. That's, I mean, shitty FaceTime, you have a worse delay. So
Mm-hmm.
I was thinking, like, what if the idea of like sending everyone there, and we got to be able to mine everything and grow everything and like you said, move all of industry. What if we're looking at that the same way we're looking at firefighters and bowler hats with big pneumatic leather wings? Like, what if there is something we're not even like? Have you seen iRobot? Remember that movie?
Yeah.
Will Smith. Do you remember like the robot carriers they have? They're those big, like, kind of like one directional, like,
Mm-hmm. Yeah, I know what you're talking about.
buses. Yeah, they open up and all the robots jump out. I mean, who's to say that we just don't send like a rover on steroids, like one of those, and then you have a bunch of these Boston
Oh,
Dynamics
that's,
robots,
yeah. I mean, that's
and
a
then back
serious
here on
idea
Earth,
that's loaded.
let's say back here on Earth, you have a bunch of scientists and trained people getting into VR avatar suits.
So you can't do that because the delay is too much. It's over half an hour. The rovers are actually, I was listening to a podcast about this really recently. They were talking about driving Curiosity, because the team that drives the rover is all working from home, right?
Yeah.
And they're making jokes about, which Xbox controller are you guys using? And they go, no, we actually don't do any driving because the delay is way too big. They go, the rover is way more autonomous than you think it is. We just like point where we want it to go. But the level of autonomy and capability to do what you're proposing is not there yet.
Yeah.
I think the two things needed to really do it, like, realistically, what we need to do is we just need to wait, and we need to do R&D. We need to be happy with playing around in near space, on the moon, do R&D to make things better, learn from our mistakes that we're going to have, trying to do stuff on the moon and in a near Earth orbit. But we need to work on autonomous construction like that, because that would be ideal. Even if the rockets are slow, if we can just have robots building the industry there, it would be great. Or we need to go way, way, way faster, because we're talking about not being able to get help. But if you have, you sidestep all of these chemical rockets, you sidestep even most nuclear rockets, you move on to like really, really serious far future sort of nuclear rocket technology, you could talk about like a week to Mars.
Yeah.
And that starts changing the game to like, wait, maybe we could ship stuff.
What if so, like, thinking about like the delay, what if you could send like something that's never meant to land on Mars, like the humans, not, it'd be like,
Oh yeah, like a space station.
think about like, yeah, like 10 ISSs like bolted together, and they operate the robots on the surface. Because we can, I mean, Mars, you got to travel there, but I mean, like, we know how to do the ISS. We do it. We're doing it now. We've been doing it for a while.
The ISS is highly dependent on Earth, though. We ship up food and water and air all the time, and it's within the Earth's radiation shield. We would have to heavily build a bigger one. Like, the rads are really scary. I mean, imagine, so the number of particles is not as bad as what I'm about to say, but the general scale is. Imagine stuff like a quarter of the energy of the Large Hadron Collider, like the big ass accelerator in Europe. That's what's flying around out there. So stopping it isn't, just a little sheet of lead. This is way worse than, like, the total number is not as bad. That's why you don't just instantly die when you go to the moon. But the long-term accumulation is way worse than if you were to have to deal with, like, say, the radiation we deal with from a nuclear reactor. Because the radiation from a nuclear reactor is really weak. That's why we can really easily stop it. The only problem with it is there's just a lot of it. But the radiation up in space is like, it's like some drunk jackass with a particle accelerator is just firing randomly. So it's really hard to stop. And that's why, people always talk about, if you're going to go for deep space travel, which Mars is deep space, your options are to either put a ton of shielding on. And I mean literal tons. Like you need like 1 ton per square meter of spacecraft. Or you got to really go fast. Because another big danger is if you're out by Mars, or you're even on your way to Mars, and there's a solar flare and that sucker hits you and you're not in a shielded spacecraft, and I mean, like, big serious, we're going to hide from a nuclear bomb shielding, goodbye. Like, you're going to have a really nasty death. You're going to be puking up your insides for 3 days while your hair falls out.
Yeah. Straight Chernobyl. Yeah.
Yeah.
I mean,
it's like you're rolling around in a blown up RBMK.
Well, RBMKs don't blow up, Garrett. You're delusional.
They're perfectly safe.
You're perfectly safe. You didn't see it because it's not there. But so, what about Elon's Boring Company? Could that have dual purpose? Go to Mars, just immediately dig down?
Sure, but there's nothing unique that they're doing with their digging. The only thing that Boring Company's done is they're digging with smaller digging machines to dig a bit faster. But like, their digging machines are the same digging machines we've been making. Digging is hard. Like, that's why a lot of people have been crapping on Elon on the Boring Company specifically, because he came in and he helped, especially with space. I have my opinions on Tesla, but SpaceX specifically, amazing stuff. That was a huge innovation in the field. It really disrupted everything, and it was a field that was ripe for it, because there's not actually that much money in space. Especially when Elon first got into that, there wasn't this massive market that we're always drawing people. There's a huge barrier to entry, and it wasn't drawing all of this interest. But man, do you know how much freaking capital is spent on digging? Do you know how many people work on making digging slightly better? It is insane. Think of all of the projects everywhere in the world that need digging.
Yeah.
There are people constantly working on this, and there are hundreds of billions to probably trillions being spent on digging.
Yeah. Well, I mean, I had a guy on the other day, I think on Sunday, who literally just operates this big ass caterpillar like earth mover. And he talked about it. He was like, it is so much more insanely complex than you could possibly imagine. He's like, there's like digging theory. He's like,
oh yeah.
He's like, when you have these things that get, gallons per hour, he was like, it comes down and it's all about just repetitive. You're going to be doing this little up and down the strip mine 100 times a day for the next 5 years. It comes down to like, he's like, it's things that you don't normally think about. It's like how to have the lowest number of rotations, how to like use the machine as little as possible in the most efficient way. And he's like, these things are like, some of these earth movers are like, these are like multi-million-dollar machines.
Oh yeah, they're all massive and custom and very expensive, and like there are innovations. I'm positive there are innovations to be had within the sector, but I really doubt any sort of massive SpaceX disruption, because there's just so many people working on it all the time. Like, if you work for whatever, digging manufacturing company or, big engineering company, and you say, hey, I have an idea for a better digging machine. They're not going to laugh you out of the board. It's not like if you say, I have an idea for a better rocket. They'll be like, yeah, whoop-de-doo. No one
Yeah.
makes money on rockets.
Yeah.
They'll go, really?
Yeah.
Give the pitch.
Yeah. Give the, yeah. We'll sign them. Yeah. It's
Yeah.
like, yeah.
They'll spend the money to play with it because, you know, you think not just infrastructure digging, which is always happening, but mining. Like you brought up the great thing with the strip. Like, dude, if you could make mining even slightly cheaper,
Yeah.
that's a money printing machine that you just made.
Because it's, I mean, because any money saver or any increase in efficiency, you can just multiply it. You just multiply. Okay, you're saving a penny. Okay, now multiply it by a fleet of 10,000 dump trucks on 10,000 projects. You know, a million
Exactly.
man hours a week. It adds up. It adds
Yeah.
up.
And especially when you can save money on either save money or increase production at the lowest levels in the system. It's like when you save money on electricity, right? Energy is usually the big driver. It's like what we talked about last time with cheap energy.
Yeah.
You make the lower end stuff cheap and it affects everything else way more.
Yeah. 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 I mean, I'm trying to get someone. It's like this company in like Belarus. Is that Belarus still a country? Is that one of the? Okay.
Yeah, Belarus is right next to Russia.
Yeah. Okay. Yeah. I was thinking of like Czechoslovakia, like the countries that don't exist anymore.
Mm-hmm.
But yeah, their company is called Belaz, Belaz, and they just made a dump truck. It can carry 496 tons. It's the biggest Caterpillar ones I think are 350. This one it looks like a shitty Photoshop until you see it moving around. You're like, oh, this is real. But yeah, I mean, I watched a video on it and it's like, it fits into all the same dimensions of like existing. So you don't need to like overhaul the whole like industry. It's like, it fits into the same bays, like barely. I mean, it's like putting a cruise ship through a canal, but yeah, man. And it's this entire thing about, it's has two engines working when it's hauling, and then one of them can flip off while it's like going back down. But it's like, you don't really think about it. You're like, oh, it's a dump truck. How much more advanced can it be? Truck, dump shit in, dump shit out. But no.
Dude, some of those mines are using fully automated electric dump trucks because they found that it saves that much money for them.
Yeah.
And they're monsters. They're these huge monsters that I was reading an article talking about how they were saving money on tires and brake pads because the automated ones stopped slightly better than the humans. And that added up.
Yeah. Yeah. And you also got to think about you're right. If you can remove, make it more accessible, think about China. China controls 90% of the world's rare earth metal trade, but they only have 30% of the world's ore.
Mm-hmm.
So if you can find, that's not trivial.
I speaking of that, I really think advanced mineral extraction is going to be very big in the coming years because of ecological impact and economic conflict with places like China and economic concerns over things like slave labor and whatnot. Because we've been slowly working on these really advanced techniques for a long time now.
Yeah,
and I think we're gonna start seeing some very cool stuff in the coming probably decades of extraction of rare earths from all the coal waste that we generated over hundreds of years. Like there's so much in there and it's just in a big pile. You just go start digging it out and separating it, but chemically separating it's difficult.
Yeah.
Or another cool one is uranium extraction from seawater. Oak Ridge has shown off uranium seawater extraction at about 4 times the current market value of uranium. But that thing you just put it in the ocean. Yeah. It's like a sponge. It comes out. You put it in a solution of acid. Then you take the thing out and put it back in the ocean, and you just have uranium right there. Like you're
printing money.
Yeah, you're just printing it. Yeah, it's incredible. And you don't have, modern uranium mines aren't very impactful on the environment just because you don't need to pull that much uranium for the amount of energy you get. But imagine if you didn't have a mine.
Yeah.
Like you just have this thing I saw a concept out of China where they were talking about putting these suckers. It was like an offshore wind turbine. It looked like you mixed an oil rig and an offshore wind turbine station. So you had like 2 or 3 offshore wind turbines, and they were powering the seawater extractors that took it through the filters and then extracted the uranium from that. And then just like every month, a boat comes out, loads up, tons and tons and tons of purified uranium and takes it into, fill up reactors.
Jesus Christ. Yeah, I mean, what if I was thinking,
And the ocean's got tons of other stuff in it too. We just have to figure out how to pull it out.
yeah, no, yeah, the ocean's a fucking treasure trove. Least of which, or not least of which, is the water. But
Yeah.
yeah, that little necessity. I was thinking, what if you could like nudge, instead of asteroid mining and trying to bring it back to Earth, what if you just could nudge it and have it impact Mars, and you could just sort of get your shit there?
Oh, for terraforming or for
Not
just
even
getting
terraforming. I wasn't talking about the impact. I mean, just like, why ship a ton over there when you could nudge 100,000-ton chunk of
So
platinum?
the problem is Mars already has most likely everything you need. It's the extraction equipment. It's not that you need you're not going to be sending raw platinum or whatever. You're going to mine that. You need the mining equipment.
Okay.
And the smelters and the factories and all of the other stuff. It's how to restart, because what we're talking about with building a colony on Mars is restarting all of Earth's industry in a place with no air and toxic soil and high radiation. And it's like, man, that is a ask. That is a big ask, because we don't even know how to do that right now. If you had to restart civilization right now, you'd have a heck of a time. You'd be like, man, I think I can make some fire, and that's about it.
Yeah.
But you have to completely build civilization again, and you're limited in what you can ship. And everything that you use has to not need air, because air is real precious, because the humans need to breathe the air.
I think it's gonna have to be robots then. Yeah.
Yeah, I agree with you. I mean, I think the two things I was laying out are really what's going to have to come into play. We're going to have to develop automation way more, and we're going to have to make better spacecraft. Like we have to go way beyond thinking about chemical propulsion. We got to be faster. We just have to, because or we need to be able to haul more stuff. Because if you take a really powerful rocket, you take this big nasty like Orion drive, the one where you throw the bombs behind it, right? You could go to Mars really fast, or you could haul tons of stuff and go really slow.
Yeah. Yeah.
And so if you have that sort of rocket technology, what's nice is you can make these human movers that are, they're like supersonic, or they're like jet travel for today. Those will zip. They'll get to Mars as fast as you possibly can to keep the humans safe. And then you'll have the cargo movers, and they'll be like cargo ships, and they just coast on in.
Yeah. Do you think is the move to just start sending more and more rovers that would have like dual purpose? Like we could cannibalize them when we get there.
I don't think the rovers have enough material on them to be worth it.
Okay.
I think right now we got to use like NASA's budget for science is so small anyways, and they get so much amazing stuff done. We just need to support them to do that sort of stuff. When it comes to doing any sort of colonization work, let's practice on the moon where we can screw up, because the moon is basically as bad as Mars. Like radiation's nasty. There's no air.
Yeah.
There you go. Oh, and the ground's toxic, just like Mars. So, you're in the same ballpark of problems. If you can make things work on the moon where you can still call for help, then we can start talking about going to Mars.
Yeah. Yeah, you could definitely, you can see the value in that stuff though. Mars, the moon, because we're always like, we need a backup plan in case of an asteroid. And then we're like, well, what about nukes? What about coronavirus? Like, we'll get it grind this place to a halt. If you had someplace on Mars or the moon, it's gonna just keep trucking.
I mean, kind of like humanity could realistically, the shutdowns for coronavirus were good because we care about human life.
Yeah.
But 1918 flu, things didn't shut down because we didn't care.
Yeah.
And like the world kept barely rolling. So we can make it. I don't like the backup planet mentality just because I would rather do everything to defend Earth. I just think it's good for us to expand outwards because, this planet's full of life and we got to care about it. We need to not ruin life because it's the only planet we found with it. But the rest of the universe, from what we can tell, screw it, burn it all, mine everything, turn it into our little fun paradise, right?
That's my mindset.
Yeah. I'd say the only places we care about are the places with life. Like if we go to Europa and Europa's got living things, cool. Don't touch Europa.
Yeah, don't fuck with it.
Let stuff lives there. To a point, I don't know if I care that much about bacteria, but
novel stuff, keep it. But I mean, shit, got some valuable stuff.
Let's go with mercury, right? Nothing's living on mercury.
Yeah.
I think we should strip mine mercury,
down to an apple core. Just pull it down. Yeah.
It's got the best solar resources in the solar system. So you have all the power you could ever want. And if our understanding of solar system formation is correct, it should also have the most heavy metals. So we should be able to go there and just be like, oh yeah, all the platinum.
Just eat it. Just eat. Fuck it. Can we just bring it with us?
We're gonna tear it apart to make the Dyson swarm.
Good. Yeah.
That's right. That's where you get the resources from, right? Just tear Mercury apart.
Yeah. Maybe the move is we move all the heavy industry and stuff off Earth.
That's Jeff Bezos's thing, and I like that idea. As much as we can, just to try to keep this place like a park.
Yeah, exactly. Yeah, keep it pristine, keep the grass.
And anything on Earth needs to be lowest possible environmental impact. I mean, that's
take the Jersey Turnpike shit. Just go put that on the far side of the moon. Who gives a fuck?
Yeah.
It's
far side of the moon's for science. You got to leave that alone for a perfect radio astronomy place.
All right. Okay. Yeah. We'll just
near side. You can do the near side. Burn the near side.
Burn the near side. Yeah. Yeah. Or trash and stuff. I don't know if you've ever heard some people are we're already polluting other planets. I don't give a fuck. Go throw it all there. Go throw it on the moon. I don't care. Shoot it into Jupiter. I don't give a fuck.
If it doesn't affect living things, it's not pollution.
Yeah. Exactly. Throw it all out there. And if anything, that will just kickstart life somewhere else.
Yeah.
All of our trashes. I mean, it's all.
Yeah. I mean, I would say if we go through the solar, let's say it's 200 years from now, we've gone everywhere and we've looked everywhere and we don't find any other life. It's our duty to spread life everywhere.
Yeah.
Literally.
Just.
We're unique.
Yeah. Start throwing trash everywhere. I mean, but really, I mean, it's all how much organic trash do we have? How much RNA and DNA infected shit do we have?
Yeah, we'll just make some gene engineered stuff that'll just start living everywhere.
Yeah, just fuck it. Yeah.
Anyways, man.
Yeah.
I gotta go.
Yeah, 3:00. Garrett Brewog, thank you very much for coming on. And as always, man, it's a pleasure. Let's definitely do another one. Good luck with whatever you got to do. I'll see you, man. Peace.